Today we're going to talk about something new and different. We're going to talk about the MKS Monster 8 in its version 1.0. Now I'm going to walk you through what's on the board, and in future tutorials I'll actually talk in more depth about the functionality, but for now I'm just going to show you what exists. So as you can see, the processor right here is going to be an ARM processor. It's actually an STM32. I'll show you a little bit more detail about this in just a second. It also has a boot button and a reset button. Now you may or may not need to use these in order to load firmware on your SD card to the actual board. But what I'm going to talk about right now is just the functionality for the moment. So what you can see here are the stepper drivers. So there's 0 for driver 0 all the way up to driver 7. So there's 8 steppers. Now they can be used for the x-axis, the y-axis, the z-axis, or they can be used for multiple z-axes or x-axes or y-axes. It depends upon the actual pinout file, and I'll show you how to deal with that in a second, or at least understand it. And then there's going to be jumpers that you're going to need to set for either SPI or UART inside of here, or your regular step DIR drivers. Over here we have our EXP1 and 2. In most of the displays that you'll be working with, it may be backwards from the other configuration, so you may have to swap the cabling to EXP1 to EXP2 and EXP1 to 2 in the other direction. So that's just something I want to let you know about in the future. Over here we have our diag pin enable jumper cap pins that you can see. This will enable sensorless homing. But down below this we have our actual end stops, so you probably have X, Y, Z, and then these may be used for other functionalities such as run out or other things such as power down, but that depends upon your configuration. As you can see in here, there's an I2C set of pins, a CAN bus set of pins, and also UART set of pins for other devices. Then over in here, it looks like you have a jumper configuration for either I2C or CAN. So if you jump from here to here, you can actually select what you're working with. I'm not exactly sure how it works just yet. Then you can see the SWD set of pins. This is used for software loading generally in the factory, but we may be able to use that functionality as well for loading firmware. But normally we'll do it through the actual SD card and the TF connector over here. As you can see, there's another set of SPI pins down here. I'm not exactly sure how they operate just yet. Then we have an RJ45 connector right here. We have a USB card connector here for reading from a USB drive. And then we have our normal USB-C type connector, which we'll use to connect to the actual computer. Over in here, I skipped some stuff, so let me point out that you have some stuff for, I believe this is for a LED set of displays, but I could be incorrect because it says 5 volts in G. I might be misreading this. And then there's also a 3D touch in here, which also can be used for a BL touch, but I think that's a jumper, so we'll have to research that further. Then down below we have our thermistor set of jumpers, and what thermistors are a wire that has a glass bead in the center. So when your temperature is turned on through the ports up in here for your either thermistors or heat bed, what will occur is temperature will be controlled by how fast electrons travel through this actual connection from one side to the other through that glass bead. So I've covered a lot of the functionality except for the fans over in here. And what you can see is you can adjust the actual fan speed. I believe you can do either 12, 24, or 5 volts, but we'll have to check the manual to verify that. And the jumper caps will be used to adjust the voltages. Now over here we have our power supply, and I believe our bed temperature, and then these would be our extruders up through here. So I've covered most of the functionality that's on this board, at least where the pins are. Now I'm going to walk you through how to actually research it. Now a lot of it is written on the actual silk screen, which would be the writing on the board. And on the reverse side of this board there's more. But what we need to know is our chipset. We can find this from our actual manual on the website, or we can zoom in on it and see what it is. So this will apply to a lot of other boards, but let me zoom in so you can see it. So as you can see, down below it says STM32F403. That's our processor type in this situation. So let's go over to the computer for a second. And what I'm going to show you now is actually how to set up the Marlin firmware. So the cool thing about this is Marlin publishes firmware from now and again. This is the most current, which is 2.0.9.3. Now, different firmwares that they publish will do different things. Most of the ones you see right here are for 8-bit processors, and then up here it's for both 8 and 32-bit processors. Now we're working with a 32-bit processor, so we need to download this, which might take a few moments to actually download, and then I'll show you how to set it up. Now there are older releases. This was a stable build for an 8-bit build over here, but as you can see, it's probably not used very much. One of the interesting things you can do that I want to point out, but I don't advise doing unless you know what you're doing, is if you go to View Downloads, you'll actually be able to see the configuration for different types of printers. But let me talk about this real quick. Down here, they do a bug fix build. This is a development build. So if you do use this, remember, things are highly unstable in this because they're being developed in the bug fix build. The same thing goes for the 8-bit processor down here. So let me show you this real quick. If we click on View Downloads, this will actually be the configuration for multiple types of printers. Now, when using this, understand that it's not well maintained and will probably have issues. So I don't advise using it, but essentially what it is the ability, for instance, if you go to a Creality, you'll see that there's an Ender 3 in here. So let's click on the Ender 3 Pro. Inside here it has different board types, which have the pre-configured configuration for what they think your base model may be. So for instance, if you click on the SKR Turbo, you'll be able to pluck out these two files and drop them into the Marlin download, which I'll show you in just a second for the firmware. Keep in mind, these are not always correct because I get way too many questions on it, so I prefer not to show you it. That way you can go through my tutorials in a series or playlist and understand better how to configure each and every configuration that's inside these files. So the playlist will be listed in the description of the video. And if you have trouble seeing it, what you can do is use a different browser because Firefox allows you to see it, whereas currently Chrome does not. I don't know why on YouTube, but that's the way it is. So what I'm going to show you now is another thing. Over in here you see releases. If we were to go back up to here and click on Marlin firmware, you can find the previous build for a release by clicking on this, And then as you can see, there's a drop down over here in GitHub. If you click on this, you'll be able to see the different builds by their actual numerical designation for what they are. But you can also click on branches, which probably won't show you much. And then there's tag builds. So this is how you can actually find the last build that we were working with. Let me go back a little bit over here because I think I double clicked. So in this case, if we go to tag builds, we can click on the previous build and then scroll down, and inside of here we can see what all the things were fixed in the previous build to this build. And at the very bottom we can download the previous build. So it's a little bit further down here, but you can download the source code here, or for Unix you could pull it down here for gzip and tar. So that's one way to locate the previous build. A lot of people seem to ask me questions about that, and that's how you do it. Now what I'm going to do right now is I'm actually going to go over to the folder where we just downloaded this and right click and extract all and click extract. This is the build that we downloaded for 2.0.9.3. Now keep in mind these are always in flux and possibly have errors. So one of the ways you can actually check that is to go over to the Marlin website, and down here they have reporting an issue. If you click on this, you'll be able to search on current issues. Now these are usually the ones that just came out, but if you want to search for something like TMC 2209 and press enter, you'll be able to see what issues are occurring currently in possibly the build you're working with. So always be aware of this so you can check those situations. But let's go back to the extracted folder. So inside here we have the extracted folder. If we open this up and we go to Marlin 2-0.x, I'm mispronouncing that and mangling it, but sorry about that. You can see that there's a Marlin folder. If you had downloaded the default configuration, you would paste them over these. But currently we're doing this from scratch by design so you can see what the process is. So what I'm going to do is I'm going to go over to VS Code, which I'll put a link in the upper right hand corner on how to install this. And I'm going to click on Explorer. And this also has a Platform IO plugin, by the way, which you can actually install over here by typing Platform IO IDE, and this will be the current one right here. I already have it installed, obviously, but I wanted to show you that because it's kind of important. I'm going to open the folder. I'm going to go over to my downloads folder, my Marlin folder, my next Marlin folder, and I'm going to select the folder. Once I have this selected, what we need to do to set this up is going to be several things. First of all, the default environment over here is the Mega 2560, which means that it's not the processor we're working with. That's an 8-bit processor. So we're going to have to change that in a moment. But the way that we do that is by knowing what our chipset is, which in this case is the INI file, which is an STM32F4. And I didn't really talk about this just yet, but if we go over to the GitHub for the MKS Monster 8, we can derive some of the information from the manual if they have one. So as you can see, they do say that they have a manual. Now, I don't know which one it is, so let's click on it and see what happens. So it's saying something about configuring for a type of printer being a Varon. But as you can see, there's different configurations. They also say that you can use Klipper with it, which is another type of firmware, as well as Marlin. And they may even walk you through the steps, but I'll probably do a video on this in the future. But what we're interested in is the actual pinout diagrams in here. So I'm going to scroll through and see if we can find some real quick. There's obviously the functionality that they're talking about on the board here, and the processor and the things that have to do with like fan outputs. Note that you can't use 12, or excuse me, you can't use 24 if you're not using that PSU for your power supply. But that is best now to use a 24 volt power supply so you have range of fans that you can use. So let me find some interesting information in here. It tells you what the voltage range of your board is, being 12 or 24 volts. And also tells you about what steppers and everything else you can use. Also, it talks about different types of temperature things that you can use. This was the glass bead with the wires for the thermistor. But down here, it gives you an outline of what I just told you about the board. Obviously, they're set up as numerical motors down here, but they're associating them with things, which I'll point out in just a second. But essentially, this gives you some information about your board and how to work with it. Now, there's various ones in here. I obviously picked one that was for a particular printer, but it's essentially known as a data sheet. So, now that we know this about our actual configuration, I'm going to click on the actual config here to set it up. So in order to do this, I have to first go to the actual Marlin folder, then the source folder, then the core folder, then boards.h. Inside here, I'm going to search on Monster. And as you can see, it comes up to the Monster 8. So I'm going to copy this entire string. I'm then going to close out of here. We already know what the board type is right over here, which is STM32F407. And then it says VGT6. That's kind of not important, but they put it there so that you know that it's a slightly different chip. It is used in several different other boards. So let's minimize this and go to configuration.h. And we're going to search on motherboard. And as you can see down here, it's got the ramps for the 16-bit, or excuse me, 8-bit board. We're going to paste over that our 32-bit board configuration. And essentially, that's a pins file. So in order to find the pins file, you would click on Source, Core, then, or excuse me, not Core, on Pins. Then you'd find the actual chipset, which is STM32F4. And then down in here, you would look for the Monster 8. Now, if we scroll through here, it's going to take a second to find. It's right here. So inside of here, you can see that it's actually the configuration of the pins associated with that board. So each one of these pin numbers corresponds to a pin number on a pinout diagram. And what I mean by that is if you go back over here and you go to hardware and then you pick the board, you can see there's a pins diagram. Inside here, each one of these corresponds to what's in this file. So it's functionality you can use. Now down here it looks like they may have not marked two things, or they're not used and it's just a generic template. But now you have an idea what's in the board. So if we were to take, for instance, the diag pin for PA14, and we were to click on here, we would find that PA14 is probably in this area someplace for end stops. So as you can see, the X minimum in this case says PA14. So that's what that pin is inside that file. So now that we understand that, we're going to set up the basic compile for this. So eventually you'll need to make modifications in here in future tutorials, but I'm not going to cover it at this moment. So I'm going to go back over to the platformio.ini. And what I'm going to do is I have to change our default environment or this will not build. So I go to the INI folder, I find our chipset, which is STM32F4. And inside here, I search on Monster 8. And as you can see, there's going to be a couple of different ones. Try not to use this one, it'll cause confusion. So use this one right here, and you're just going to copy this. Then you're going to close out of this file. You're going to go over to your pins, or excuse me, your platform.io.ini. You're going to paste it over the Mega 2560. And then I have to show you some simple things over here. Over in here, you can see that it's a .pio folder, and it says Mega 2560. Before they actually release, they do a test build, and that's why you see that. So to clean that out, you're going to click on the little garbage can down here that says clean, and that'll take that information out. Now to build, you're going to click on the checkbox that says build. Now I'm clicking on it right now. This may take a few moments and may fail the very first time. If it does fail on the first build, hit that build button a second time, because sometimes things build out of order. And in this case, I forgot to set something up, and you can see that there's an actual error, and it has to do with the serial port. So what I'm going to do is I'm going to go over to configuration.h. Where we set the motherboard in here, we need to make an adjustment. So we have the Monster 8, but I forgot to set the serial port for the first serial port to -1, and that'll take care of that problem, hopefully. So I'll click this again, and this will take a moment to actually build, and afterwards it will populate our actual build inside this folder. So if you watch this folder as it progresses, it will actually populate each part of this build inside of here until we have a firmware.bin. Now a firmware.bin is a binary file. That means that there's either a 1 or a 0 in the file for each one of the operations that it needs to do in the binary. That means that it's in a language that the computer or chipset can understand, being the firmware in this case, which we're going to flash to EEPROM. Now, when I talk about the firmware, I'll sometimes refer to it as software and sometimes refer to it as software that's programmable. Essentially, it's a drive that we can reflash on the board. So, understanding that, it's actually been compiled down to, I believe, binary, but essentially it's going to give commands to move or operate our printer. So, in order to set it up, I need to actually copy it off. So inside of here, I'm going to have to find the firmware.bin, and as you can see, it comes up as MKS Monster Bin. So this is a bit different than I'm normally used to, so there may be a rename involved. So I'm going to right click and I'm going to reveal in File Explorer. Now once this comes up, we have this option or this option. So we'll start with this. If this does not work right here, we'll rename it to firmware.bin and then try and load it. But let's go over to the desktop for a second and pop out the drive. And you're going to need a card reader, and you're going to populate the card reader right here and then plug this into your computer. Now you may hear a beep like you just heard. We'll go back over here and we'll look at the drive for a second. Now it says firmware.cur, which means the last time I loaded this, it renamed it to firmware current. So we're going to try first loading this file to see if it works, and we'll send it to the drive. Now what I'm also going to do is I'm going to copy this file and paste it in the same directory and make a second copy called firmware.bin, just in case it's reading a different file name. So I'll say firmware.bin, and we'll send this one over as well. Now that'll also tell us which one is loading and which one is not, because it may not be using this one, but some configurations do this. So let's check on the drive, It's loaded for both, so whichever one's successful will be renamed to firmware.cur, in this case current. It's actually this file, it's just renamed. That's the way it will not reload a second time after it's been loaded. So I'm going to go back over to the workbench. I'm going to pop out the actual drive and I'm going to insert it into this drive over here. Now to power this board, there may be some issues with actual power. Normally you could do it two different ways. One is through your power over here, but check your actual pinout diagram to understand where these are. And also get in the habit of marking what the voltage is and what the ground is, so you know by coloration what you're plugging in, so you don't accidentally plug in something incorrectly. But I'm going to actually use the drive for this being the SD card to load with power from USB. Now this jumper might be in the wrong place, so if this powers up and doesn't work, I'm just going to move this over to the other one and then power it. So we'll know instantly if it actually works. So it doesn't work in this case. So if I unplug it and I move the jumper over here, we can power the board. So one thing I do need to say about this after I plug it in is that when you're running steppers, you want the jumper in the other position because it may cause issues with your steppers resetting. And I'm specifically saying TMC type steppers. So this is probably going to take a few moments to actually load. You just heard the beep, which tells us that it loaded. So what I need to do now is actually set this up in an environment that you can see. So I'm actually going to go over to Pronterface so that you can see this. So let me switch this over. And inside Pronterface, we're going to try and connect to it. So what we're going to do is we're going to hit the connect button here. But the problem is our COM port is COM port 1. So a way to fix this is we're going to actually go to the desktop for a second. And I'm going to type Device Manager. And this will come up in a second. I know it's not appearing where you can see it just yet. But in order to find the COM port, you'll expand this out. And you'll see that it's COM port 8 because 1 is the default for your computer. So I'll close that. I'll click the drop down. It actually is there, but if it was not, you could highlight this and then add it in. Then we'll connect. So if this doesn't work the first time, what we'll do is we'll reset the actual board. So I'll go back over to the workbench for a second. I'll power it down. Then I'll power it back up. Then what I'll do is I'll go back over to the desktop. And I'll put this so you can see it. And we'll give it a second to beep. And then we'll try connecting again. So there it goes. The beep actually happened. It's now connected. So to test this, what we can do to see if it's functional and has programmed correctly, we can say M119. And when I do this, I'm checking the actual end stop status. Now, none of the end stops are connected, as you can see down here. So they should all say triggered for the ones that are enabled. So let's see what happens. So they do say triggered for the enabled end stops. Now, I do have to thank my patrons for helping to make this tutorial possible with their donations, either via PayPal or Patreon. And I'll put a link in the description if you feel as if you want to donate or not. And I will place in the end of this video a thank you to all of them. So everyone, take care, be safe, get vaccinated, and wear a mask. Take care.